Hello and welcome to another marking video, this time about the periodic table. So this question is about elements on the periodic table. We had to fill in the sentences using the words from the box. So Newland's and Mendeleev's periodic table show the elements in order of their atomic weight. Following the discovery of protons and neutrons, the modern periodic table shows the elements in order of their proton numbers. So we order elements according to their atomic number, that's their proton number, but Mendeleev and Newlands ordered their elements in order of atomic mass. Next question. The diagram below shows the position of 9 elements in the modern periodic table. So this is the modern one. Which of the 9 elements shown in the diagram above has the lowest boiling point? That's fluorine. Okay, fluorine has the lowest boiling point. It turns to gas the easiest. It needs the least amount of energy to change its state. Copper and potassium have different melting points and boiling points. Give one other difference between the properties of copper and potassium. So their differences are that their reactivity is different. So copper is much less reactive than potassium. Potassium is very, very reactive indeed. Copper is harder, whereas potassium you can sort of slice straight through it with a little knife. Copper is stronger, hence why it is harder. And copper has a higher density. All of those things make copper great for pipes and for using as sort of change and pots and pans, that sort of thing. Okay, explain why the reactivity of the elements increases going down group 1 from lithium to rubidium, but decreases going down group 7 from fluorine to iodine. So, moving down group 1, the atom gets larger. The distance between the nucleus and the outer shell increases. More electron shielding, so there's less of an attraction between the outer shell electron and the nucleus. So it's easier for group 1 metals to lose their outer shell electron down the group to form a +1 ion. So what I mean by that is as you go down the group, the atom gets larger and larger and larger. Now group 1 metals have only one outer shell electron that they need to lose to form a +1 ion. The center is positive, it's a positive nucleus. As you go down the group, because there are more shells, there's more electrons, the atom gets larger and larger, the nuclear attraction between the positive nucleus and the outer shell electron decreases, it gets less, so it becomes easier to lose that outer shell electron and to form a +1 ion. And that's what makes group 1 metals more reactive as you go down the group. However, with group 7 elements, moving down group 7, the atom gets larger, just like in group 1 metals, but this time you're not trying to lose an outer shell electron, you're trying to gain an outer shell electron. So, more electron shielding means less nuclear attraction, which is harder to gain an outer shell electron to form a -1 ion. So, just in group 7, the atom also gets larger and larger and larger, but rather than trying to lose outer shell electrons, you're trying to gain an outer shell electron. You're trying to attract an electron into the outer shell. Now, if you have more shells, it's harder for that positive nucleus to attract that outer shell that electron into the outer shell. So that's why it becomes less reactive as you go down the group. At the top, the nucleus, the positive nucleus, and the outer shell are quite close. So it's much easier to attract an electron into the outer shell and to form a -1 ion. Okay, question 2. Part of the Newland's periodic table is shown below. So this is what group 1 used to look like, 2, 3, 4, 5, 6, 7. And Newlands was trying to show a pattern by putting the elements into columns. Iron does not fit with the pattern in column 7. Give a reason why. So iron in here is put with sulfur and it's put with oxygen, and it doesn't fit the pattern because iron is a metal whereas sulfur and oxygen are not. And also iron has different properties to iron, oxygen and sulfur. Oxygen is a gas at room temperature, whereas iron is not. Iron can conduct electricity. Iron behaves in a certain way, reacts in a certain way that oxygen and sulfur don't, because it's a metal. Okay, why did Mendeleev leave gaps for undiscovered elements in the periodic table? Well, he left them so that elements with similar properties could be placed together, and so that any undiscovered elements would have space, would have somewhere to be grouped into. Okay. Newlands and Mendeleev place the elements in order of their atomic weight. We've already talked about this. The modern periodic table places the element in order of atomic numbers, or proton number. Lithium, sodium, potassium are all in group 1 of the modern periodic table. Explain why. They all have 1 electron in their outer shell. They all have similar properties, and they all react in the same way. That's why they're put in the same group. Over the page, Mendeleev first arranged elements in order of atomic weight. Mendeleev then placed the elements with similar properties in columns, which he called groups. When the next element did not fit the pattern, he left gaps. And finally, Mendeleev was not able to include the noble gases in his periodic table, because the noble gases had not been discovered by 1869. That's why he didn't think to put them on his periodic table. Okay, filling in this sentence here with these words from this box. In the modern periodic table, elements are arranged in order of the number of protons in their nucleus. Elements in the same group have the same number of electrons in their highest energy level, outer shell. Okay, Dmitry Mendeleev produced his periodic table of elements. Mendeleev placed the alkali metals in the same group. What evidence did Mendeleev use to decide that the alkali metals should be in the same group? So, they had similar properties, and that was the main thing. He didn't adhere so strictly to whether they had the same atomic mass. He cared more about whether they had similar properties. Describe how the elements in the modern periodic table are arranged in terms of protons. They're arranged in order of atomic number, which is, of course, the proton number. So, as you go along, it goes up in order of ascending proton number. In terms of electrons, well, elements in the same group have the same number of electrons in the outer shell. And 2 properties of transition metals that make them more useful than alkali metals for making water pipes, well, they're stronger and harder and less reactive. That's what makes something like copper more suitable for being pipes, because it's not going to react with water, it's really hard and durable, whereas alkali metals very soft and very, very reactive. Last few questions then. So, how did Mendeleev know that there must be undiscovered elements, and how did he take this into account when he designed his periodic table? Well, if he placed the elements consecutively in order of atomic weight, some elements would be in the wrong groups or have wrong properties. So you'd have all these elements with different properties put into the same group, and that just didn't make any sense. So he left gaps. That's what he did to account for that. By the early 20th century, protons and electrons had been discovered. Describe how knowledge of the number of protons and electrons in atoms allowed chemists to place elements in their correct order and group. So, elements placed in the atomic number order. Elements are placed in the atomic number order. Elements in the same group have the same number of outer shell electrons. The number of protons equals the number of electrons. They're the same amount. Reactions or chemical properties depend on the outer electrons. The number of shells gives the period. So you could have said any of these 3 options. You needed it's a mark per one of those options. And there you have it. That was all of the answers to the periodic table exam this week.